Yes, hello. My name is Rainer Gerz. I'm the syslog development lead. This is my first try at Google Hangouts. What I want to do this time is give you a quick or not so quick, let's see how it evolves, overview over the rsyslog testbench. It's primarily aimed at developers or test engineers who would like to understand it and would like to add tests to it. I'm pretty eager for a new test, so hopefully we'll see some folks come up with new ones. First of all, I'd like to screen share a VM that has the environment. Let me see if that works. Present to everyone, I guess. This should now be on the screen. Here is Linux, actually Ubuntu, as you can see, where rsyslog is installed on it. Let's copy it down. It's the Git master branch. Right now, that means we are on 8.5 at the time of this recording. This is the home directory. All tests are created via auto tools, and they reside in a subdirectory named tests. So let's go down to that and have a quick look at the file. Go there. If you know auto tools, you know this pretty well. These are our tests. Some tests that always run. Some programs that always be used, and it has a couple of tests, both all as individual shell files that reside inside the test directory. Please note that tests are based on configure options. Most importantly, IMDiag, the diagnostic module for rsyslog, is required for almost all tests. So if you do not enable IMDiag during configure, you will probably be unable to execute any tests. So if you go just quickly back and go back to the home directory, so what you actually need is to do configure, and you need to enable IMDiag, and it probably to enable omstdout, which is also used inside some tests. And then if, for example, you have MySQL installed and you want to run the MySQL tests, you enable MySQL. Enable MySQL. Yeah, and so on. You get the idea. And this is because of, let's go down again. This is because of the makefile. For example, if you see MySQL here, these tests are enabled if MySQL functionality is present. It's also pretty useful to have variant on the system because some tests automatically check for memory leaks and exceptions, and these require variant. Yeah, basically the tests consist. Well, the test that I'm talking today about consists of a shell file and its related configuration file. There are some other tests that are very specific, mostly module tests that use C programs and other functionality to carry out some tests. What I'm talking about here is tests that actually run the product and actually run our system. Oh, and one important thing in that regard, you cannot do a parallel make test with the rsyslog test bench simply because we start up various instances and we require that each instance is separate. I know that new auto tools enable me to force sequential execution, but so far I had no time to look at how this is done and do it. So back to what the tests are. We have these shell file, and I'll use today the facility tests. And with the shell files, extra disk so that it goes into the tarball. we usually have one or a couple of config files. As you can see here, this fuck osprif comes with a facility osprif.conf. That's a typical pattern. The base name for the shell file is also the base name for the config file. And as you can see here, the config files are in another subdirectory, which is named test suites. If you try a little bit inside it, so there are a lot of configs. And by the way, if you look for something unusual in rsyslog, it's often a good idea to check testbench cases because they do some pretty advanced things. So now let's look at the facility test for osprif, which checks for the osprif facility. And as you can see here, the text file itself, or the test file itself, is pretty modular. We use a script that's diac.sh, and we included this via source because otherwise it doesn't work in our case. It sets environment variables and these things. And this diac.shell contains the base test functionalities. It contains things like we see here. In it is the initialization of a new test that clears up all running instances, clears up temporary files, etc., etc. So in short, it makes sure that the system is ready for carrying out a test. And quite the opposite is exit, which also clears out the test and makes the system hopefully ready for some other things. So in theory, if exit runs successfully, init should not be necessary. But that's probably important when we have some problems inside the test. So for that reason, let's first look into the diac file that you get an idea of what's inside it. That's diac.shell. And that's a kind of a framework. Here at the top, we have options to enable debugging and debugging settings, which just need to be uncommented to be carried out. And here you see, for example, what init does. We don't need to look at it in detail, but you see a lot of file deletions. Some common files are refreshed from a general location. Then this kill rsyslog.shell kills the running instances known by the test bench. We create some spool files, etc., etc. And again, the exit does pretty much, well, not pretty much the same. It removes the files. And there's a long range of commands which you can use inside that file. Typically, there should be no need to modify diac.shell because it contains everything that's used for common tests. The general idea of a test is that some messages are injected. Oh, yeah, maybe it's better to just follow what's done here. First of all, and this is common to all tests that use a single rsyslog instance. First of all, we start up rsyslog, and we give it the name of the configuration file, and that configuration file is osprif.conf, and it's automatically expected to be inside the test suites region. Then we use, in this test, a tool that's named tcpflood. This one enables us to send messages via TCP or via UDP. It has a variety of options. None of them is documented inside the documentation because it's primarily aimed at developers. And for developers, we expect that developer can read the source code. And right here at the top, all options are documented. So, for example, we have, let's go back, we have an option /m, and this tells us number of messages to send. .p is the priority, and by default it sends via TCP to port 13514. and it starts sequence numbers at 0, because it sends messages that contain sequence number. It contains a specific setting, and then each message contains the next higher sequence number. This is very useful so that we can check if all messages have arrived, if there are some missing, if there are some duplicates, and for that reason, TCP flood does it in a very easy way to pass. So what happens here is that TCP flood at this stage actually sends messages, and processing waits until TCP flood is finished. Then we shut down our syslog, but we shut it down only when its processing is finished, or better said, when its queue is empty. There's obviously a difference between when this is finished and when this is finished, simply because there are OS buffers and rsyslog obviously also buffers inside the rsyslog queue. So after we have shut down when empty, issued this command, rsyslog begins to shut down when all queues are drained. But it does not shut down instantaneously, and to prevent races, we wait for the actual shutdown. What wait shutdown does is wait for the pit to disappear. Then, and that's an important step, we have a program check sequence. That does nothing but count if the output file that we use to carry out this test contains sequence numbers between null, 0, and 999, and this corresponds to the 1000 messages. And finally, we exit. If, for example, check sequence detects an error, it sends out the autoconf expected, auto test expected status, so that autoconf detects the error as well. So in short, and this is a typical pattern, what we do is we inject messages via one way or the other. TCP flood is one way to do it. We have another tool that is less flexible, that's inject MSG, that uses an rsyslog internal plugin via imdiag to inject messages directly inside the core engine. It's a little bit faster, and it's useful for many cases where we don't need the advanced configurability that TCP flood offers. In essence, you can always use TCP flood if that's what's most important for you. Okay, so now let's look into that configuration file. As I said, it's under test suites, facility auth-priv.conf. And what we have here is also very common. First of all, we need to include this direct common configuration because it loads the modules that are required for interactions with the test bench. Most importantly, it loads imdiag. Secondly, and this is the case in all tests where TCP flood is used for TCP testing, and in many other cases, we load plugins that we need. And note, due to the special environment under which we are executed during make test, we need to use these relative paths so that we get proper relationship. Then I said TCP flood sends to 13540, and this is exactly where it is done. So you can use other port numbers, subtest, use other port numbers in order to test multi-port capabilities, for example. But if you do not really rely on TCP flood or on port testing, it's probably a good idea to stay with this base port. Then we have a special output format template, and that template uses field extraction in order to extract the number that TCP flood generates. And finally, this is done in our tests, we have auth-priv .star, and that goes to note the leading dot goes to the current directory into rsyslog.output log, which is one of the file names expected by I think either wait shutdown or check sequence. Let's have a look at direct.shell. Here's our sequence check. Yeah, what it does, it creates or removes the work directory, sends that to pre-sort, and then sorts it. Because we cannot rely on exact sequence, then check sequence is called. So this is where we have our file, and it must be this name. And the template must be assigned, of course. And as you can see, this is a legacy old style configuration. And this is intentional. It's a pretty new test. I just recently added it. An old style configuration is still important to us, at least these selector-based ones. It's pretty important that they continue to use. So what I often do is I create this test in old style, and if we go to our directory, you can see that I test various facilities. And one of them, for example, is facility mail. Let's have a look at it. Facility mail. You see the base, same pattern. Everything basically the same, it's a copy. But if you look at the facility mail conf, this states mail.conf, you'll see new style. Also note the dots that I used here. So pretty important. This uses the new style, and the other facilities thing. If you look over here, facility.conf. They have various mixes of old style and new style configuration. A lot of the test bench is old style simply because the test bench is pretty old. Some parts are pretty old, and there was no need to update that. And new tests that are being added typically get added in new style, and some of the old style constructs get converted to new style. But as an addition, so we don't remove the old style stuff because we still support it, so we must test it. And we have seen, unfortunately, in some cases that new style sometimes broke old style, or some things only worked if new style was used, or only worked if old style was used. So it's pretty important to have both types of styles available. Okay, if you want to run this, there's one nit that you actually must take care of, and this is source dir. If you run it under make this check, everything's fine, and source dir is set by AutoTools. If you don't do that, you need to set it yourself. What I have is a small file. What's it called? As? Yep. That simply sets it for my needs, and I need to include it before carrying out manual tests. And now I have two options. Obviously, I can use make check, and I won't let it run for a lot of time, simply because it takes, well, quite some time to go through. But you also see here the individual tests. So let me stop that. If you are developing new tests, you don't want to run the test bench half an hour just to test your test. So once you have set up the environment, it's software, etc., and you have created the test tools, which you do by running make check. Then you can just use the shell file. What was it we used? See, this is part of the startup cleanup process, I interrupted this test here, and it left an instance of rsyslog running. And the startup process detects that this happens. And so it says rsyslog PDEX is trying to shut down, and that's what it does. And then we start a new rsyslog instance, and these messages, actually, all of them come from TCP flood. It tells us how many connections it opens. Typically, we have just one. There are some tests where we intentionally use multiple connections. Then it tells us how many messages will be sent and have been sent. There's runtime indicator, and it closes. And then everything was okay, so we don't get any further messages. And I'm back, just tells us the main queue is empty, and that's it. So that's pretty boring, and it's good if it's boring. So if we want to test a new facility, let's say, or if we want to have this fail, then let's go into test suites facility force proof, and let's comment this out for a moment, and now say this mail. And if we look at facility force proof to test, we use this priority setting. We don't use mail priority. We use Osprey severity. So with mail it should work, and hopefully we'll get somewhere over here. Yep. This file does not even exist. And that's the case because rsyslog just create the file, pardon me, create test files only if we have messages for them, and we didn't have any mail messages. So let me push everything into it, and that won't work either, simply because we see a scanf error in index I equals 0. And if that happens, our work files exist. So we have work pre-fold, and we have work pre-fold. We see field not found because these are startup messages, etc., etc. It's not what we expected. And same over here after the sort, and this is why we receive error messages. And the test bench actually captures it. Oops. So let me reinstantiate this test. Hopefully I worked out well. Yeah. Okay. So what do you need to do if you want to create a new test? Basically, the idea is that you look at the existing tests, quite a bit, maybe find something that that you can use for your use case, or use something as simple as the facility test that I used in my testing. And just modify it where necessary. Well, let's have a look at the tests. Which facilities do we have? Local 0. We don't have local 7. So, for example, let's create a new test local for facility local 7. What I do is copy the old one. That would probably be a good idea to facility local 7. And I need to create a new config, facility local 0.conf, and that goes to test facility local 7.conf. and I need to edit both of them. Local 7 and test states facility local 7. So what I need to change here is relatively simple. The date, maybe. Just to be a nice guy. Then I need to change the config file. So far I didn't bother to put the base name of the shell file. It's not really a big change. I keep the 1000 messages, I keep the root process, but I need to use a different facility because that is local 0. And I happen to know that local 7 is, do I happen to know, is 191 is 2 minus 8 is 8, 184, and I think 185, we are right in the middle, hopefully. Testbench will tell us. And then we need to go into the config file. Again, this all stays the same. This also stays the same. But we check for local 7. And this stays the same. Okay. So in theory, that should now give us a new test for local 7 facility. Yup. And if I intentionally use the wrong facility, I think we are at 129. Okay, wrong facility now, then it should complain. And indeed it does. So let's fix it. Oops. And let's recheck. Yep, works. So we can now use it manually, but that does not mean the testbench will execute it. Obviously, we need to make changes to the makefile. And in this process, it's also useful to look at tests that we already have. What was it? 0, for example. So we see a test here. And as our test is pretty much the same, we just can add it. And we must not forget the extra list for the distribution timer. And change that over here too. Yep. Now it should execute it. Must rebuild the makefile, obviously. And now the tests are carried out. As proof, local 0, and there are new local 7 tests. And let me stop that and shut down the instance that's running. Okay. Actually, that was what I wanted to tell. It's a tiny example, but I hope it's a good one to grasp the idea of how the testbench works and how it operates. It's probably worth noting that the testbench is also automatically run each day. And whenever I receive a failure, or whenever the testbench fails, the automatically run testbench fails, I receive an error notification. And this is pretty much a lifesaver for development and for creating software that works. As I said, tests, new and additional tests are appreciated. There can never be enough tests. They should follow the framework because that makes it easy for me to integrate them. If you create a totally different test that still runs with autoconf, no problem. I'll look at it and I'll try to integrate it as well. Yeah, that's it for now. I hope the Hangout was useful. I'll review it myself soon. Feedback is appreciated, especially as I want to create additional series of these things. Thanks and bye.